This is section 6.1, cubic and quartic functions. So we're going to look at the basic shapes of cubics and quartics, just for reference. All right, so we're going to look at x cubed, negative x cubed, x to the fourth, and negative x to the fourth. So x to the third is a cubic, x to the fourth is a quartic function. So x to the third power, if you were to graph it in your calculator, it's going to look something like this. So the left side is going down. The right side is going up. Then we have negative x cubed. So if the number in front of x cubed is negative, it's the same general shape. It's just essentially flipped. So on this one, the left side is going up, and then the right side is going down. If you graph x to the fourth, it kind of looks like x squared. So the left side goes up, and the right side goes up. Now, depending on what the equation is, you could have little bumps, but basically we're looking at the ends. The ends are going in the same direction. With a cubic, the ends are going in opposite directions. Right, negative x to the fourth, so if whatever number's in front of x to the fourth is negative, it's just going to flip it down. It's going to open down. So the right side opens down, and that's the left. Side opens down. The right side also opens down. So cubic to the third power, the ends open or go off in the opposite directions, and then for the quartic, the ends go in the same direction. So again, we're just going to be looking at the general shape for these. On these, they want to know what are the x-intercepts, and you may have to make the graph bigger with the pop-out feature. So the x-intercepts are just where it crosses the x-axis. We're not worried about the y. So it crosses at -4, at 1, and 3. What is the sign of the leading coefficient? Leading coefficient is the number in front of the variable or the letter with the highest power. You go back up here, which one does it look most like? General shape. It looks like x cubed because the bottom is going to the left. The right side is going up, the left side's going down, so that's just x cubed. That means the number in front of x cubed is positive. Again, because the left is going down and the right is going up. So that tells me the leading coefficient is positive. And because the ends go in opposite directions, it's cubic. You can also identify this from the general shape and looking at the original ones that we graphed. All right, what are the x-intercepts? Just the x-axis, not the y. So that's -7, 3, and 5. 3, and 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3, 3, 5. 3 You look at the general shape and look at the original ones that we graphed. This looks like negative x cubed, so the leading coefficient, the number in front of x cubed, is negative. And since the ends are in the opposite directions, it's cubic. So see, right is going down, left is up. This one is similar to negative x cubed. So that's where the leading coefficient comes in as being negative. Ends are in the opposite directions, so it is cubic. For the x-intercepts, we cross right here and right here. This is a negative 6.5, and this is a positive 6.5, and they do want decimals on these. The left opens down, and the right also opens down. If we look at the original, that is similar to negative x to the fourth. So the leading coefficient is negative. Since the ends go in the same direction, it's quartic. X-intercepts. See that? It's a negative 3.5, and that's a positive 3.5. Just where it crosses the x-axis, not the y. The left side opens down, and the right side opens down. This looks similar to negative x to the fourth. So the leading coefficient is negative. And since the ends go in the same direction, it is quartic. This one, we're going to graph it, not for specific points, but just to get an overall shape. So we're going to flip over to the calculator. And at this point, I shouldn't have to go over how to graph again. This isn't a standard window, so readjust your window to a standard window. We'll get the general shape here. That's just what we need. We don't need, like I said, specific points. All right, so if we look at this, the shape that it looks most like is x to the fourth. So the degree is the highest power. The highest power is going to be a 4. The coefficient, the number in front of x to the fourth, is positive. Since it's x to the fourth, that means it's quartic. So the left side goes up, and the right side goes up. Right, so the degree of the polynomial, that's the highest power, is 4. The leading coefficient, the actual number itself that's in front of x to the fourth, is a 6. The curve opens up to the right because the leading coefficient is positive. because the polynomial is quartic. The graph has n behaviors in the same direction. So the other end opens up to the left. So now we have another one we need to graph. Can't see the bottom of the turn down here. I know it's turning. All right. So this one looks like negative x to the third. So the left side opens up and the right side opens down. So that means the degree is 3. That's the highest power is going to be x cubed. Our leading coefficient is going to be negative. And since the ends go in the opposite directions, this one is actually cubic. All right, so let's find the leading coefficient. Let me show you how to do that. All right, so we have the -2 that has the highest power and that has the highest power. All right, so we have -2. The number in front of x is 1, and the number in front of x squared is 1. So that is our leading coefficient. You're going to multiply those. The degree is 3 because that's the highest power. Our leading coefficient is -2. The curve opens down to the right because the leading coefficient is negative. Because the polynomial is cubic, the graph has n behaviors in the opposite direction. So the other end opens up to the left. Reminder, this is a video, so you can pause it if you're not finished copying stuff down. And let me take this back. I just want to go back to a standard window. All right. See what's happening there, what it looks like. Left opens down. The right opens up. This looks like x cubed. So the degree is the highest power, which is going to be the cube, the 3. The leading coefficient we see is going to be positive. And because the ends go in the opposite direction, we know it's cubic. Degree is 3. Let's look for our leading coefficient. So there's x and an x squared. There's a 1 in front of there and a 1 in front of there, and you multiply those and you get a 1. So the leading coefficient is a positive 1. The curve opens up to the right because the leading coefficient is positive. The polynomial is cubic. The graph has end behaviors in the opposite direction. So the other end opens down to the left. Specific points don't matter. We just need the general shape. Left opens down. The right opens down. Looks like x to the 4th. So the degree is our highest power, which is the 4. The leading coefficient, because it opens down, actually that's going to be negative x to the 4th, is negative. Since it's going the same direction, it is quartic. All right, the degree is 4. So we have a negative, that's like a -1, and then you have the 7, and then in front of that x squared, there's a 1. So you have a -1 times a positive 7 times a 1, which gives us a -7. So the leading coefficient is -7. The curve opens down to the right because the leading coefficient is negative. Because the polynomial is quartic, the graph has end behaviors in the same direction. So the other end opens down to the left. And this is it for section 6.1.